Decomposed algorithm for reducing time. Complexity in binary search. Abstract, searching is one of the principal tasks in computer science. Binary search is one of the most common and efficient algorithms used. Binary search targets the middle element and checks for the target key in the list. The worst-case time complexity of binary search is O, log, n, where n less length of the search list. In this paper, we have proposed a fast and efficient approach to binary search by decomposing the main search list into multiple search lists. The time complexity for the proposed algorithm is O, log, k, where kn and n is the length of the sorted list and k is the length of the sublist. Keywords: binary search, algorithm efficiency, sorting and searching, time complexity, decomposed algorithm. Introduction: binary search is one of the well-known searching techniques used to search the key value from the sorted set of data. The algorithms for binary search can be found in many classic textbooks such as Algorithms in C1 and Introduction to Algorithms, 3rd edition 2. The algorithm of classical binary search constantly targets and checks the mid-element of the sorted list. The binary search can be implemented both iteratively and recursively. The proposed algorithm works very similarly to the binary search. It searches the list using an element as its basis and comparing whether or not present in the list in a given iteration. However, unlike the binary search, the presented algorithm, instead of searching the whole list, it searches in the decomposed list, which is always smaller than the original list. The time complexity in the worst-case scenario in linear search, binary search, and the decomposed binary search are n, log, n, and log, k, respectively, where kn and n is the length of the sorted list on which the searches are implemented and k is the length of the decomposed searching list. A popular of searching approach. There are multiple techniques for searching data. Each searching techniques have their pros and cons. The most commonly used searching algorithms used are linear search, binary search tree, and more. We will discuss some of these popular searching algorithms in this section. 1. Linear search. Linear search is a widely used searching algorithm in computer science. In linear search, each element is checked to start from 0th index to the end of the list. The time complexity of linear search is O, n. 2. Binary search. In classical binary search, the complete search array is repeatedly divided into halves. The key is searched in the left half if the middle element is smaller than the key, else key is searched in the right half. The process of division of left and right half continues till the key is found as per the condition of the middle element and search key. Fig. 2. 2. Literature review. 1. Donald Knuth proposed uniform binary search. The proposed algorithm stores the index of the middle element and changes in the middle element between the next two iterations. The main disadvantage of this algorithm is that the proposed methodology is only quick in those cases where it is unfit to calculate the middle point. 1. 2. Bentley et al. Proposed exponential search in 1976. They proposed the new searching algorithm by targeting the first segment with an index which is time complexity at the worst case of the classical. The power of 2 and greater than the target value binary search algorithm by comparing the input. And then shifts to binary search. The main element with the first and last of the data set. 8. Disadvantage of this proposed algorithm is that it is only fast than binary search when the target value is near the starting index of the array. 2.9. Similarly, there are much research works on 3. Chasles et al. Proposed fractional cascading in searching techniques for different purposes. E.G. 1986. The authors proposed an efficient searching Fibonacci search. 9. Quantum binary search. 10. Technique. The proposed algorithm splits the sorted ASH search. 11. Each algorithm has its pros and array into multiple sorted arrays and performs the cons searching operation in each sorted array. The main disadvantage of this proposed algorithm is that it 3. Proposed approach needs some extra space, which increases the space in the proposed decomposed binary search approach first. Complexity, and so increases the expense of we derive the binary equivalent of the length of the main list. Searching 3. Each of the ones in the binary representation is converted to 4. Praveen Kumar proposed quadratic search in the power of 2 corresponding to their positions, where the 2013. The proposed algorithm is the advancement of binary search. The algorithm targets 1/4, middle, and 3/4 elements of the sorted array, and index starts from 0 to k1 and only the values greater than or equal to 1 is stored in the list. The reverse of the new list created is the decomposed list. The main idea behind the searches for the target element if the target element creation of the decomposed list is to reduce the search time is there in the target index, then it will return the by reducing the search space. So the decomposed list index of the target element or else continue to consists of the distribution of indices from the main list. Search by reducing search space as per the where the key could be found out. So each element in the condition. The biggest disadvantage of this decomposed list will be represented as the index of the algorithm is that a lot of condition is to be checked main list whose value can be equal to or less than the key. If to reduce the array to find the target element and the value of the element in the main list referenced by the also have to maintain more pointers for decomposed list is equal to key than the key is found or 5 Nitin Arora etal proposed two-way linear search else if the value is less than the key then the element. In 2014, the authors proposed a searching referenced from the decomposed list in the main list algorithm in which they used 2 pointers, first at becomes the high value and the value of one index less than the beginning and the other at the end of the search. The referenced index in the decomposed list becomes the array. The first pointer is incremented while the low value, and if the key is less than the first value, second pointer is decremented in each iteration to referenced from the first index of the decomposed list as the find the target element in the search array. The index of the main list then it becomes the high value and major disadvantage of this proposed algorithm is 0 becomes the low value. Now, we have the high end. Maintaining multiple pointers in linear search 5 the low value which we will pass to the binary search. 6 Alwyn Francis etal proposed modulo 10 search function which in turn will reduce the time complexity by an alternate to linear search in 2011. The only searching the sublist of the main list. So by comparing, authors proposed a searching algorithm for finding the decomposed list value as an index of the main list from the target element in the search array. By getting the key we can directly say where is the probability of modulus 10 of the number and the list will be the element found, which is way faster than searching the divided into 10 lists based on modulo 10 of the whole list. Number 64. Proposed algorithm. 7 Karthik Soundarajan proposed odd-even based decomposed binary search, list, n, b, b_n, search. Binary search in 2016. The authors proposed a purpose, to get the subset of the given array for which the searching algorithm by sorting the list into the odd possibility of occurrence of the element is highest part and even part and then implement the binary input, list 0, and 1, the list of sorted elements. Search technique based on the type of search, n, the number of elements in the list. Element. If the search element is odd then the b binary representation of the length of binary search is only executed in the odd part of the list array and the same for the even key element, binary, b_n, no of ones in the search will be executed in the even part of the array. Binary representation. The proposed algorithm works efficiently only if search, the key to be searched. The array is provided in sorted on an odd even, revdec 0, k1, reverse of basis 7 decomposed. 8 Ankit Archada etal proposed the modified list binary search algorithm in 2014. The proposed output, decomp_list 0, k1, the list of the algorithm checks the presence of the input element decomposed set elements in the power of 2 of with the middle element of the search array in each the length of the main list. Iteration. This proposed algorithm optimizes the end of step 9 loop step 10, exit. Once the decomposed binary search algorithm is executed we will get the high and the low value for the main list which is then passed to the classical binary search algorithm reducing the space and time complexity of the search. V implementation. Consider a list of 13 elements in sorted order arranged in ascending order. Fig 4. The binary representation of the length of the list is 1101. Here the position of maxterm is at 3 so we convert it to the power of 2 which is 2 cubed equals 8 which means the first subarray will contain 8 elements whose index will start from 0 to 8 to 1 equals 7. The next position of 1 is at second position. The power of 2 will be 2 squared equals 4 which means the second subarray will contain 4 elements with minterm 7 plus 1 equals 8 and maxterm 7 plus 4 equals 11. The last one is at the minterm which is at position 0 so we have 2 to the power of 0 equals 1 term in the last subarray having minterm as 11 plus 1 equals 12 and max term as 11 plus 1 equals 12. Fig 3. Now, let us say we have to find key equals 56 from the main list. Our algorithm will first compare the element at index 7 in the main list, which we can see is main_list decomp_list 0 equals 7 equals 57 key, hence the high equals 7 and low equals 0 is returned, which is then passed to the binary_search function as an argument. Where decomp_list 0 is the first element of the decomposed list formed. Note, in the algorithm, we have used revdeclist to denote the decom_list to ease the calculation. Had tested our algorithm with datasets with more than 1000 pages to find different search keys and compared the steps encountered in the classical binary search to our proposed decomposed binary search. Fig 6. Here we took a random dataset of 1023 pages and applied classical binary search and our proposed decomposed binary search to find 1851 in this dataset. We found that binary search took 9 steps and our binary search took only 6 steps to find the index for the same given key after the decomposed algorithm is implemented on the main list. Fig 7. Here again, we took the same dataset, but this time we applied both the approach with different key I.E2236, and again we found that our proposed algorithm is efficient over the classical binary search approach. Classical binary search takes 9 steps to identify that the search key is not present in the given dataset, where our proposed approach identifies the same in 6 steps. Fig 8. Now, again we took another key 3008 in the same dataset and found that the classical binary search approach took 9 steps to find the index of the search key, where our proposed approach took only 1 step to find the index of the search key when the decomposed algorithm is implemented. 7. Conclusion. After applying multiple datasets and different keys in the classical binary search and our proposed searching algorithm, we found that the algorithm we proposed to find the search element in the datasets is more efficient and faster. The time complexity of the classical binary search is O log n, where the time complexity of our algorithm is O log k, where k n and n is the length of the sorted list and k is the length of the sublist.